This is a laser pointer from eBay I've got for only 70 cents including shipping. And as usual it comes in a plastic envelope. I've got two different versions of them. And when one of them arrived, it wasn't actually working, and I was thinking it's because it's just rubbish, but the reason was that there was a plastic ring inserted into the battery compartment so that it doesn't get discharged on the way. And this is quite clever, so it works really well. And I have two different versions. This one has a laser pointer in it and a white LED flashlight. This is another version. It also has a red pointer, but the other button is for ultraviolet LED, a money check or whatever. It's quite nice. And those are quite useful, especially if you have cats. So let's take a look at the batteries in it. There was the plastic ring I have already removed. And there are the batteries. 1, 2, 3 batteries, 3 button cells, LR41 plus soda, AAA button cell. That's really strange marking. It's definitely not AAA. And I don't expect any soda inside it. And the other one has exactly the same size of the batteries, just the marking is a little bit different. This is AG3 button cell. Let's measure what current does it draw. This is going to be harder than I thought. Okay. White LED draws about 26, 25, 23 milliamps. It's going down. And the laser draws about 20 milliamps. But I think I'm reading a lower current because of the resistance of the multimeter, and the actual current is probably a bit higher. And the other one, about 20 milliamps for the ultraviolet one, and 18 milliamps for the red one. This is almost the same, and I think the batteries are already partly discharged. What does the sticker say? Avoid exposure. Laser radiation is emitted from this aperture. Danger. Laser radiation. Avoid direct eye exposure. Not direct. direct exposure. Nice. And the maximum output is less than 5 milliwatts. Or actually less than 5 megawatts. It's quite a powerful laser, isn't it? But I guess the real power is about 1 milliwatt. And it's funny how the lasers always say less than something. So even a 0 would be true. This is a really good device, especially for its price, which includes the shipping and the set of batteries. But the only problem is that the batteries last a really short time. They really don't last very long. And the reason is that the batteries are very small and very low capacity. I found a datasheet of the batteries, which are AG3 type, with the capacity of only 24 milliamp hours. And I remember when I was a kid I had a laser pointer which was a little bigger, and it was using AG13 batteries with a typical capacity of 110 milliamp hours. And that's really quite a difference. This is the battery size comparison. This is what the Chinese laser pointer uses, and this is what my old big laser pointer was using. And another problem is that those batteries are designed for very low current appliances. And the typical capacity of the battery in datasheet is measured using a 30k resistor, which draws about 0.05 milliamps only. And this is much smaller current than the actual current of the pointer, which is about 20 milliamps. So the current is almost 500 times more than the datasheet expects. So this is the reason why the batteries last even shorter than I would tell according to the capacity. Because if the current is about 24 milliamps and the capacity is 24 milliamp hours, it theoretically should last about 1 hour, but in reality it lasts much shorter time because the battery is not designed for high currents. It is designed for very low currents being drawn for a very long time. So with bigger batteries the operating time would be much longer. So let's see what's inside. The white LED ones are much harder to find on eBay, so I will keep this one. And I will disassemble this one with the blue or ultraviolet LED. The housing seems to be made of metal, probably aluminium. And there is a spring contact inside. The whole metal case is a positive and the spring contact is negative. The operating voltage is 3 times 1.5 volts, which gives 4.5 volts with fresh batteries. The entire housing is one piece of metal, so how do I open it up? Should I pull it out somehow or should I begin with this side? Okay, let's try. Does it screw? Oh, it just pushed in. Yeah, it comes apart quite easily. There are the buttons. And this is the whole thing. 2 microswitches. A tiny board with the contact for negative. And there is some resistor under the wires. And this big metal housing is probably for the laser diode, and those 2 wires are probably the ultraviolet diode. I can pull this out. And there's the LED. And there is the laser diode. How this is mounted here? There is some sheet of metal or another piece of PCB under it. It's not even soldered, it's just shoved into the gap. There is a contact on each side of the board. There is a piece of copper plated board. What? Wait. There is just the lens in it. And is this the laser diode? Really? Now I'm really surprised. I was thinking that this piece of copper is just some contact to make a contact with the laser diode, but no. This piece of board is the actual laser diode. So this is how Chinese make cheap laser diodes. Oh, can you see the die? So this piece of metal, which I was thinking contains a laser diode, is actually just a housing with lens, a screwable lens in here, and this is the diode. So basically they just stick this board into the gap and then they focus it by rotating this lens in its plastic housing, and it seems like they probably slightly press the metal housing here to prevent it from rotating further. And the ultraviolet LED is just a boring 3mm through hole LED. which is probably rated for about 20 or 30 milliamps. I'm not sure what the current rating of the laser diode is. The buttons are nice. This is much better quality than just a metal foil pressing against the board. And let's make a schematic of this. And the schematic is going to be quite simple. There's just a battery going to an LED and a laser diode. And the ultraviolet LED goes directly to a button and to negative. And the laser diode goes to a resistor, then to a button, and then to negative. And the resistor is 560. So this is 56 ohms. The schematic is quite simple, and as usual in Chinese designs, this LED has no resistor at all. The current through this LED is only limited by the internal resistance of the battery. And because the voltage drop of this LED is close to the voltage of the battery, the current is not very high. But fortunately, this laser diode has a series resistor. But to calculate the current, we would have to know the voltage drop of the laser diode. I have somehow managed to put the remains of the diode into my breadboard and measure its voltage drop. And it's about 2.2 volts. So the battery has 4.5 volts, the voltage drop of the diode is 2.2 volts, and so the resistor should see 2.3 volts. And the current is U over R equals 2.3 divided by 56, and this is 0.041, and this is 41 milliamps. But because of the internal resistance of the battery, the actual current will be smaller, and it will also decline as the battery discharges. So this is Diode Gone Wild, and see you in my next videos.